Investment-specific technological progress refers to progress that requires investment in new equipment and structures embodying the latest technology in order to realize its benefits. Introduction. To model how something is produced, think of a box that in one end takes in inputs such as labor, employees, and capital, equipment, buildings, etc., and in another end spits out the final good. With this picture in mind, now one can ask, how does technological progress affect production? One way of thinking is that technological progress affects specific inputs, arrows going in, such as equipment and buildings, to realize the benefits of such technological change for production. These inputs must be purchased. So for example, the advent of the microchip, an important technological improvement in computers, will affect the production of Ford cars only if Ford Motor Co.'s assembly plants, the red box, invest in computers with microchips, instead of computers with punched cards, and use them. They are one of the arrows going in the box. In the production of Mustangs, the arrow coming out, as the name suggests, this is investment-specific technological progress. It requires investing in new machines or buildings which contain or embody the latest technology. Notice that the term investment can be general. Not only must a firm buy the new technology to reap its benefits, but it also must invest in training its workers and managers to be able to use this new technology. Greenwood and Jovanovic, 2001. Importance. Identifying investment-specific technological progress is important, because knowing what type of technological progress is operating in an economy will determine how someone should want his or her tax dollars to be spent and how he or she may want to invest his or her savings. Gort et al. 1999. If investment-specific technological change is the main source of progress, then one would want his or her dollars spent on helping firms buy new equipment and renovate their plants, because these investments will improve production and hence what you consume. Furthermore, one may want to help pay for current employee training and using new technologies to keep them up to date, or subsidize the education of new employees who will enter the job market knowing how to use the new technology. So, the type of technological progress will also matter for unemployment and education issues. Finally, if technological progress is investment-specific, you may want to direct your money towards the research and development (R&D) of new technologies, like quantum computers or alternative energy sources. Russell, 1998. More generally, why is any type of technological progress important? Technological change has made our lives easier. Because of technological progress, people can work less, make more money and enjoy more leisure time. Greenwood and Vandenbroek, 2006. Women have been able to break away from the traditional housewife role, join the labor force in greater numbers. Greenwood et al. 2005. And become less economically dependent on men. Greenwood and Gunner, 2009. Finally, technological progress has been shown to affect the fall in child labor starting around 1900. Greenwood and Seshadri, 2005. Figure 1 illustrates this last point. In 1900, child labor's share of the paid labor force began to fall. A simple example: the microwave oven. An example of investment-specific technological progress is the microwave oven. The idea of the microwave came to be by accident. In 1946, an engineer noticed that a candy bar in his pocket had melted while working on something completely unrelated to cooking. Galloway, 2005. The development of this good, from melting the candy bar to the home appliance we know today, took time and the investment of resources to make a microwave small and cheap. The first microwave oven cost between $2,000 and $3,000 and was housed in refrigerator-sized cabinets. Galloway 2005. Today, almost any college student can enjoy a 3-minute microwavable meal in the smallest dorm room. But a microwave's uses do not stop at the dorm room. Many industries have found microwave heating advantageous. It has been used to dry cork, ceramics, paper, leather, and so on. Galloway 2005. However, for either college students or firms to reap the benefits of quick warming, they must first invest in a microwave oven that embodies the technological advance. To realize the benefits of investment-specific technological progress, you must first invest in a technology that embodies it. How do you measure investment-specific technological progress? While measuring technological progress is not easy, economists have found indirect ways of estimating it. If investment-specific technological progress makes producing goods easier, then the price of the goods affected, relative to the price of other goods, should decrease. In particular, investment-specific technological advance has affected the prices of two inputs into the production process: equipment and structures. Think of equipment as machines, like computers, and structures as buildings. If there is technological progress in the production or creation of these goods, then one would expect the price of them to fall or the value of them to rise relative to older versions of the same good. Figure 2. The pink line shows how the price of new producer durables, such as equipment, in the US relative to the price of new consumer non-durables, like clothing, has consistently declined over the past 50 years. Gort et al. 1999. To calculate the relative price of producer durables, divide the price that firms pay for the durable inputs of production by the price that a regular consumer pays for things like jeans. We use relative prices so we can say how many units of equipment can be bought instead, or in terms of buying 1 unit of consumer goods. Figure 3. The pink line says that over time, firms have been able to buy more and more units of equipment instead of 1 unit of consumption, especially when we take into account that the quality of equipment being acquired has increased. A computer today is much faster than a computer 5 years ago, and we should take that into account when comparing their prices. When changes in quality are not taken into account, which is wrong, it looks like the price of equipment has not decreased as much. See the black line in Figure 2. Measuring the price of structures is more complicated than measuring the price of equipment. But economists have again been able to get an idea of how much progress there has been in structures, such as buildings. One approach is that if newer buildings were constructed or designed using newer technologies, then they should be worth more than older buildings, because they embody the new technology. Gort et al. 1999. In particular, they should rent for more. As Figure 3 shows, this is true. Renting a square foot in a new building is much more expensive than renting a square foot in a building 40 years old. So it must be the case that you are paying for a nicer, more functional and maybe even safer building. Figures 2 and 3 suggest that investment-specific technological changes operating in the U.S. The annual rate of technological progress in equipment and structures has been estimated to be about 3.2% and 1%, respectively. Gort et al. 1999. Greenwood et al. 1997. Conclusion. In the second section it was mentioned that investment-specific technological change is important, since it will affect production, both in quality and size. An important question then is, just how much bang for your buck do you get with investment-specific technological change? The answer is quite astounding. Economists have found that 37% of growth in the U.S. output production is due to technological progress in equipment and 15% is due to technological progress in structures. Gort et al. 1999. Greenwood et al. 1997. All in all, more than half, 37% plus 15% equals 52%. Of the growth of the U.S. economy is due to investment-specific technological change. Gort et al. 1999. Greenwood et al. 1997. Galawa, J. Carlton, 2005. Who invented microwaves? Gort, Michael. Greenwood, Jeremy. Rupert, Peter. March 1, 1999. How much of economic growth is fueled by investment-specific technological change? Quote, Economic Commentary. Federal Reserve Bank of Cleveland. Greenwood, Jeremy. Gunnar, Nezzi. 2009. Marriage and Divorce Since World War II. Analyzing the Role of Technological Progress on the Formation of Households. NBER Macroeconomics Annual 2008. 23. 231–276. DOI. 10.1086 593,087. Greenwood, Jeremy. Herkowitz. ZVI. Krussel. Per. 1997. Long-run implications of investment-specific technological change. American Economic Review. 87. 3. 342–362. Greenwood, Jeremy. Jovanovich. Boyan. 2001. Accounting for Growth. In Charles R. Holton. Edwin R. Dean and Michael J. Harper. New Developments in Productivity Analysis. Chicago. University of Chicago Press. Greenwood, Jeremy. Seshadri. Ananth. 2005. Technological Progress and Economic Transformation. In Philippe Argion and Stephen N. Derlauf. Handbook of Economic Growth. Amsterdam. Elsevier, North Holland. Greenwood, Jeremy. Seshadri. Ananth. Yorikoglu. Mehmet. 2005. Engines of Liberation. Review of Economic Studies. 72. 1. 109–133. Greenwood, Jeremy. Vandenbroeke, Guillaume. 2006. Hours Worked. Long-Run Trends. In Lawrence E. Bloom. Stephen N. Derlauf. The New Palgrave Dictionary of Economics. 2nd ed. London. Palgrave Macmillan. Krussel. Per. 1998. Investment-Specific R&D and the Decline in the Relative Price of Capital. Journal of Economic Growth. 3. 2. 131–141. DOI. 10.1023. A. 1,907,101,518,509. Le Bergot. Stanley. 1964. Manpower in Economic Growth. The American Record Since 1800. New York. McGraw-Hill Company.